discuss the general innovation tool. Especially these tools are very, very important for the ICT innovations also. That's why I am going to discuss all the innovation tools. Then you can select the suitable tool for the ICT. And the tools can be divided into the several categories: general innovation tool, product innovation, managerial innovation tools, process innovation tools. Likewise, there are four types of innovations tools. So these innovations tools are very, very important to develop your innovation and also do the right innovation for the for the right idea. So when we consider first the general innovation, tool, actually general innovation, benchmarking, brainstorming, business process re-engineering, change management, technology audit, technology forecast, value analysis. Likewise, there are several tools, and from these tools, there are some important tools which we have to discuss in deep. One is the brainstorming, and also business process re-engineering. Though are very famous tools that we can use for this innovation under the general actually these tools can be used for any innovation. When it is a technology innovation, we can use the brainstorming, or else the product innovation or the process innovation, we can use these tools. Business process re-engineering is actually, we have to introduce the business process engineering, or else we can say as the BPR, is when we consider the business process, we have to do the radical changes without changing the inputs and outputs, with the radical changes. And also we can introduce the technology for the process, but automation of the existing system is not a business process re-engineering. It has to be you can make a radical changes by introducing the ICT or the technology. But when you automate the system, existing system, is not a re-engineering. Then that is called the fundamental rethink and do the radical changes of the process. So benchmarking, when we go by one, benchmarking is the process of improving the performance by continuous identifying, understanding, and adopting outstanding practices and processes found inside and outside an organization, company, public organization, university, and college, etc. How can let's try to understand how to do this one. Benchmarking is a process of improving the performances. How to improve the performances? I continuously analyze the process and see whether which step can be reduced, or else how to integrate the processes. If the process has several steps, we have to find the processes that can be integrated, and identifying and understanding and adapting the outstanding practices, so that sometimes we can introduce the technology, or else any other method to improve the process and the practice. And for that we can get the inside and outside help. So process can be found in the insides and outside, so we can use this. One is benchmarking. We can simply say online systems provide the online system for the existing systems. Recently I heard that issuing a certain license, one ministry wants to introduce the online system to get the license. So that is also a benchmarking. And introducing the what we call, we need to nowadays we need not to go to the banks for the transactions. Right? If you want to remit the money, if you want to pay the bill, and also if you want to see the balance in your accounts and transfer the money to someone else's account, you need not to go to the bank. You can use the e-banking. You can use the e-banking system, and you can log into the, if you have an account, you can log into the system and you can do it. And that also a certain benchmarking. The process can be, process has been improved using the technology. So benchmarking of a business is usually done with the top performing companies in other industry sector. This is feasible because many business processes are essentially the same for the sector to sectors. Actually, when you consider this, introducing this benchmarking, the business can be increased, need not save, then people will adopt the system because they need not to go to the places where they want to get the help. Even in the even in the even in the what we call the license, driving license issuing, motor and traffic, uh, also use this online method for that. Next one is brainstorming. Brainstorming is an idea. Brainstorming is an idea generating method widely used by the team for identifying problems. So brainstorming sessions, actually, when a certain when a company wants to develop the product or a service, uh, there is an opportunity. For that opportunity, the company wants to develop a product or service. In such case, the idea is given to the R&D department. R&D department get the resource person, actually researchers, and do some brainstorming sessions. Then conducting some lectures or the workshops, and give the knowledge to think towards that idea. That is called the brainstorming. Brainstorming is an idea generating method widely used by team for identifying problems. So I am going to discuss this brainstorming in detail because this is very very important. Not today, but next week I will do it. Alternative solutions to problems or opportunities for improvement. Having conducted these brainstorming sessions, the people who involved to that will have a good idea, and they will think towards that the given idea, and will be developed a good product. Actually, this method originated 1941 by Alex F. Osborne, when his search for creative idea resulted in the unstructured group process for interactive brainstorming that generated more and better idea than individual could produce working independently. Actually, this must have a team having some different specialties. From the different specialties, gather the team, create the team, and do this brainstorming session. Team brainstorming has become a commonly used word in English language as genetic team for creative thinking. Genetic team for creative thinking. This is very very important for the innovation. And re-engineering, as I also explained, re-engineering is the fundamental rethink and radical redesign. Fundamental rethink, but you have to understand the input and output will not be changed. The process must be changed. The fundamental rethink and radical redesign of the business process to achieve the dynamic. Why we use the re-engineering? Because we want to reduce the time, reduce the cost, or improve the quality, and provide the satisfactory service for the people. So having those objectives, we will do the re-engineering. Minimize the time, maximize the profit, reduce the waiting time sometimes, improve the quality and provide the better service for the people. So re-engineering is a fundamental rethink and radical redesign of the business process to achieve the dynamic improvement in the critical contemporary measures. These are the contemporary measures: cost, quality, service and speed, etc. When these two tools are very very important for the innovations. The product innovation tool. What are these product innovation tools? Quality function. Actually, when you consider quality is the highest concern component of the product development. So we have to consider this quality function deployment. We can define the quality function deployment as converting the consumer's demand into the quality characteristics. The consumer's demands into the quality characteristics. What are these quality characteristics? And developing a design quality for finished product by systematically developing the relationship between the demands and the characteristics. So actually, when you whatever the product, whether it is household item or any other product, especially in ICT also, IT also, when you design a system, you have to consider the user friendliness and UI UX and the actually user experience. You have to consider the user experience, that is UI and UX. That means user friendly UIs must be introduced to the system, because most of the users of the systems are not highly qualified for the computer science. They can have a literacy knowledge, so that even for those people can easily use and get the work done from the system. So that's why we have to normally use this one. And also, if it is a product, use the ergonomics and how to, then easy to use that product. The shape of the, if it is a certain item, if there is a handle, the shape of the item, height of the handle, likewise different characteristics must be considered for this quality function deployment. And the main thing of this quality function deployment is the house of quality. That step of generation the quality. Identify the customer attributes. What are the customer attributes? Whether he is highly concerned about the color or else the shape, and those are the external features, and also the functions of the products and user friendliness likewise. And also identifying the supporting technical characteristics. Supporting technical characteristics, how to solve these technical characteristics, how to, if it is electrical item, you have to do these things, technical characteristics. And also correlate the customer attribute with supporting technical features. Normally the general user may not have a deep knowledge about the tech, they are not technically competent, not all, but majority of the people are not highly competent for the technology, or technically not competent. In such case, how can they troubleshoot if there is a problem? And simply you have to understand about that and assign the priority for the customer requirements and the technical features. Customer requirements as well as technical features. And we will evaluate competitors' strengths and the products. If you have a competitor, you have to think, analyze the competitor's product and what are the features of those products. Then address the features that is not satisfied by the customer. they may have a feature that will not fully satisfy the customer, so that you have to address that feature and how to satisfy the customer, like, and also identify the technical characteristic to deploy the final product and design. So that's why before developing the system you may have a certain sketch about that. Then after that, after the sketch, do the prototype and use the develop the prototype and see what are the adjustment, what are the changes that want to do. Then finally develop a certain from the prototype, develop the system, or else the product, and give to the users and get the comment from them, whether it is easy to use or difficult to use, or convenient or inconvenient of using, and what are the additional features that won't. Likewise, get the feedback from the users, and once again change according to the feedback, and do this process 2-3 times, and finally you can develop the good product that according to the customers, satisfying the customers attributes and the technical characteristics. Here is the quality function, normally called the house of quality. First, you have to identify what are the customer requirements, and the customer requirements benchmark and competitor analysis, so that you know the customer requirement. You have to give the priority for the customer requirement. Then you can get the benchmark the customer requirement and competitor analysis. If the competitor has a similar products or the substitute or any other thing, you have to analyze those products, and from these requirements and these two, you have to design the characteristics of the product or the system. You can design the characteristics of the, even when you design the system, you have to understand if it is if you have some UIs, UI in the button, color of the button. Inside the button, there may have a certain command. Letter size of the command, colors of the letters, everything must be considered when you are designing this system. Actually, UI UX design is very, very important for the system. Then after addressing these design characteristics, you can get the relationship between the customer requirement and design characteristics. What are the customer requirement? Are these characteristics satisfy the customer requirement? And then you have to do the technical correlation about these relationships and other things, technically how address. And finally, design scope, technical benchmark and competitor analysis design. You can finally design the system. This is called the house of quality. You have to start from the customer requirement and then the benchmark the customer requirement and also competitor analysis, design, then address the design characteristics and get the relationship between the customer requirement and the design characteristic. Correlate the technical correlation. Then having this one, consider that this is if it is a system, how you can do this one. You can easily think, for an example, consider the website for a customer. Then customer will give the requirements. Then customer requirement benchmark. Then what are the customer requirement, and you have to benchmark this requirement. And competitor analysis means you have to analyze the similar websites, and the design characteristics. The UI UX, when you give the requirements to the UI UX designer, he has to analyze these characteristics and he has to design what are the color theme of the this one. And normally create a wireframe. Wireframe means not the actual one, just to see the positions of each one, and then correlation between the customer requirements and the design characteristics. He can design it and correlate that the customer's requirement, and then normally get the feedback from the customer. You can get the feedback from the customer whether customer is if the customer is satisfied. So then technical correlation, then you can design the system using the using some Photoshop or any other any other package. You can design it, and not only design, but uh, you have to use the actual. When you are going to technically design the system, you can, after designing that, technically correlate uh, the system. So, for an example, if that system needs the backend system, what are the technologies you can use? You can use the backend or from the Laravel framework, or if you use the PHP and MySQL, you have to use the MySQL databases, PHP, and likewise. Then finally, you have to design score and technical benchmark and compute analysis design target, so that then fine tuning of these things. Likewise, anything you are going to do, you can use this quality house of quality to enhance the quality and to get the high satisfaction of the users of or the clients. So managerial innovations. What are these managerial innovations? Basically, we can use failure model and effective analysis, peer evaluation, team building, ISO standards, and total productivity management. Let's see. Failure model and effect analysis, FMEA, normally called the FMEA, failure model and effective analysis, is a powerful quality assurance discipline. This is the powerful quality assurance discipline used to identify and minimize the effects of potential problems. This is very, very important. Minimize the effects. Identify and minimize the effects of potential problems. Not the problems, actually potential problems. The problems that can be happen in product or process design. The product or process design, the potential problems can be addressed prior to occur them. The techniques was formalized by NASA actually in mid 1960s. The first used the Ford North America 1972, and now used by GMH, Austin and Ford. These two companies are now being used. Next one is Ishikawa fishbone diagram. That also one of the important concept for improving the quality. The solution is there, improvement of total quality. To improve the total quality, this is like a skeleton of the fish. That is the fishbone diagram. That is called the fishbone diagram. So for this certain process, there must have a set of methods, the manpower, and the material, and the money. And not only that, but there may have some other things. So when you go to this slide, you can get the good idea about the Ishikawa fishbone method. We'll see now. It will take some time. Will Anyway, it will take some time, so we will continue the lecture. So here is the complex one. Extended Ishikawa fishbone diagram. For the money also, you can we'll start from the method. For this method, selection, rejected, and management and reporting, as well as communication. These are some branches of this method. We have to have a report system for this one, how to manage the method, and if it is a project, the selection criteria, and communication between methods. And manpower also, you can have these managers, trainers, coordinators. If it is a IT company, you can find the project manager, tech lead, senior software developers, software engineers, and database administrators. Likewise, you can find a set of this manpower for this to improve the quality. And materials, if it is IT company, the materials are the computers and other related items. And here in this case, material manuals, training and hard copies, equipment, projectors, slide making facilities. Likewise, the money is a very important part for this one. The consultant fee, charges for the place or training materials, or the if they want to conduct the brainstorming sessions, the training, it will take some money to arrange these training materials. The pay to will have to pay the research person, and likewise. And financing improvement projects, approval is needed. Likewise, you can explain from the this is the extended Ishikawa diagram, and you can extend this diagram for the each and every step for improving the process or product quality. Then peer review, peer evaluation. Peer evaluation, actually the teams have specific goals, and team members have learned that the team goals cannot be accomplished unless everyone participate and work together. You know that team is the together everyone accomplish more. That everyone must contribute to that one, and teams have developed a shared strategy which allows them to evaluate their progress. Actually, team member is given a certain task to fulfill. So each and every member contribute equally to develop a certain to satisfy a certain task, the given task. Evaluation of this process of each one separately is actually that peer evaluation. The team leader can evaluate individually whether they are they have done the work, or they are if a certain particular person is getting late for this one, or he has done a given task very well, or there may have some clarification, and the team leader or evaluate the progress of the team. That's why you can, when you work, you can understand when you go to the industry, they may have the pocket meetings within the teams. The team will meet only 5 to 10 minutes time and discuss what are the difficulties they have, and whether they have achieved the given task or the progress of the given task. And unless they have met the targets, so others will help or advise to do speed up the process. Teamwork also very important. Team is the together everyone accomplish more. That means everyone must contribute that. Team is a group of people working together as a common goal. So they are going to achieve a common goal. The team building is the process of enabling that group of the people to reach their goals. Each one must contribute for the common goal. Otherwise, if someone gets delay, or else he is not competent to do that one, the given task will not be finished the given time. So it is therefore a management issues, and the most effective form of the team building is that undertaken as a form of management consultancy rather than as pure training. So that's why team must have a leader, and others must support to the leader. Leader will conduct the team, then allocate a different tasks for the members, and they have to fulfill. And also team leader must get the progress of the given tasks in time to time, sometimes every day or once a week. They have to get the output of the they have team leader must get the feedback. That's why in your mini projects also we are going to get the feedback in different levels. Submitting the proposal, then you have to prepare the presentation and give a certain time to finish the 60% finish the project, and once again get the presentation and see whether you have done it. You are then after completing the project, once again we are going to get the presentation and demonstrations to see whether you have done the project well. The team definition actually group of people whose individual members share a common goal, and their expert skill and personal abilities are complementary. Actually, it is its members' work activities and skills are purposefully and smoothly linked together. That's why the each module is given to the your group member. The modules can be integrated in order to develop the final solution of the system. The team effectiveness actually dynamic balancing among the necessity of to perform the joint tasks, individual needs for the team members, and necessity of maintaining a team. Actually, team leader must have a certain characteristics. I am not going to discuss here. Actually, we have to discuss it in the project management. Team leader must have a characteristics, and others must he must control the team members, and he also must have a knowledge, more knowledge than the others. Otherwise, the team leader is cannot control the team, and all must listen the team leaders team leader. Otherwise, team leader will find some difficulties to manage the team. Synergetic effects actually every member contributes to perform of the mutual task, adopt the specific role necessary for the effective team functioning, contribute to the satisfaction of the individual needs of other members. When you consider the successful team characteristics, team members identify themselves with the team. So everyone must know the abilities and weaknesses. So if someone has weaknesses, if other must can help, so that they have each other they must help to the others also. So there is a relax, non-bureaucratic atmosphere. Bureaucratic and non-bureaucratic atmosphere. You know that bureaucracy is a command. When you consider the army, police, and forces, they are maintaining the bureaucracy. And when the juniors must salute to the seniors, and there is a ranking system, but in a team there is no such things. Very relaxed, non-bureaucratic atmosphere. Everyone must work in a friendly environment, and also the team leader can advise and give instructions, and others must ask those things. Interest in achieving joint goals, not in the personal goals. They have a target to achieve a common goal, and optimistic work mode, not the pessimistic. And I personally have some experience of working such teams. Actually, if a one person is there in a team, the whole team concepts will collapse. uh, if I don't know whether you have experience, if one person is there with the contradictory ideas or else different ideas, others cannot work. Very embarrassing actually, always struggle and not contribute well. And if others work, he or she will criticize the work and also criticize the personal things and everything, so that the team must have a common goal and work as if all are same. Okay, the task and goals are clear to all members and all identify themselves with them. And also another one is the team member must not be partial to the team leader must not be partial to the team members, and not he has to treat equally for the all team members. Otherwise, if he treats someone to someone more, others will criticize it, and also it will help to reduce the morale of the team. And differences in the opinions are accepted, and difference of the opinions are accepted, and disputable points are discussed, and a solution is looked for. So criticize, the team members can criticize within the team and find a solution for that one, and after that it will finish. They work in a friendly environment, and communication is open. You can openly communicate with each other. And also uh, spotless and fluent, they can criticize and they can communicate each other, and also in a friendly level. The team leader also not in a, as a team leader, not like a teacher and the student relationship, just like a friendly relationship must be maintained. And team members are sincere to each other, be very helpful. If someone delays, others must help and get his work also in a certain point, and listening to each other. Criticism is constructive, and it is not taken personally. The criticism is very very important, that is constructive. Sometimes they criticize the work in order to correct it, not to uh, harm to that person. And it is very very important, and after that it is not taken personally. And team management is of the participative, eventually consulting character. Rules are clearly defined within the team. Rule must be clearly defined. And also in my class also, I have given you a certain rules, and everyone must come to the participate to the lecture. And also today morning also I advised to the third years, they have to come to the class and they have to do some homeworks and write the assignments. Those are the some rules. From today I'm going to start the presentation sessions. That also another one. If someone delays, or someone a certain group did not do the presentation, and they cannot get the marks, so I have clearly given the instruction to the batch. So unsuccessful team characteristics: the team members do not identify themselves within the team, and these are the weak points. Strained atmosphere, blocked communication is the team members hide their real feeling and opinion. So block the communication, and did not give the opportunity to speak, and doing that one, the team members hide their real feeling and opinion. So I have that experience also. If I am not given the atmosphere to work, then I have a negative feeling. If I have a idea to develop a certain thing, and but the the leader will not give me a chance. In such case, that will be a negative, create a negative feeling and cannot get the real output from that person. Automatic supervision, discussion about the goals and tasks not allowed. Automatic supervision, discussion about goals and tasks are not allowed, and uh, diversity of opinions leads to conflicts. Diversity of opinion to lead the conflict, and disagreement is not openly expressed. The discussion is undermined. The personal issues are settled by means of the criticism, people gossip, and also the leader must have these characteristics. Not to ask the gossip, and also the personal, they may have the personal problems. And if I have a personal problem, problem when I have told it to the team leader, the team leader must not tell to the others. That is the personal matter. The personal matters must keep as a secret. And if the leader can give some advice or any uh, advice or any other warning or thing, he must personally give to that person, not in as a group, and never disclose those things to the group. And the rules are not clearly defined, and also rules also must clearly define, otherwise the team will fail. Team structure and organization. The formal teams, and there are two types of team: formal team and informal teams. Formal team clearly visible, represent distribution of work among the team members in order to ensure performance of the certain functions. The informal teams influences procedures, which is things are actually done. Prestige of the people, their influences, power, seniority, ability to convince others play a role there. So that formal teams, we can have a certain structure also. Set of rules is manage these formal teams. Advantages and disadvantages of the teamwork. Plus things are mutual cooperation and support. Mutual cooperation and support. The questions things are the teams often accept more risk than individual. Just normally, as a team, you can accept the more risk than individual, and also can produce the high quality idea as a team. And if someone gives the idea, the others will give some opinion for that one to refine that idea, and finally can be created a very good idea, and can produce the high quality ideas by accepting the conflicts and exploring difference in the individual members' opinion. So next we have to discuss the process innovation tools. What are these process innovation tools? So especially these are the process innovation tools designed for manufacturing and assembly, DFMA, and lean thinking, continuous improvement, concurrent improvement, and just in time. These tools can be found as the process innovation. And DFMA, designed for manufacturing and assembly. DFMA is a proactive and concurrent design process. Proactive before doing that, and concurrent design process that allows for early consideration of manufacturing aspects. Design for manufacturing and assembly, actually this is the proactive method to improve the concurrent design process. Also, the purpose is to generate an environment where a cross-functional teamwork together to optimize the design for cost-effective manufacturing. The purpose is to generate an environment where a cross-functional team works together to optimize the design for cost-effective manufacturing. So let's see this simple video for that.
DFMA is a methodology for optimizing a new concept or an existing design with respect to manufacture and assembly by reducing the number of components or processes needed. By eliminating excess components, we also eliminate the drawings of these components, the need to keep them up to date, the risk of wrong production of the components, the need to store them, as well as the risk of incorrect assembly of the product itself. The cheapest component is one that does not exist. The DFMA process consists of 4 steps: conceptualization, analysis, redesign, and conclusion. To understand each of these steps, we are going to apply the DFMA process to a simple everyday product, a tea set, which includes a teacup with an ear, a saucer, and a spoon. The teacup, its ear, and saucer are made from ceramic, while the spoon is made from stainless steel. During the conceptualization phase, we review the user requirements of the product. So what are the user requirements of a domestic tea set? Well, from a functional standpoint, it needs to be able to hold a hot liquid. It should be possible to pick it up easily with one hand without getting burnt, and to place it on a flat surface like a table whenever needed. It should include a mechanism for stirring the liquid, and it should protect other surfaces from spillage. And finally, from a commercial standpoint, it should be affordable and attractive to the target market. During analysis, we assemble the product piece by piece on paper to build an assembly diagram. An assembly diagram consists of 5 different types of objects: components, processes, combined components, the main assembly, and sub-assemblies. The goal of analysis is to uncover at this early stage any excess components or processes which may exist. A component is made up of a single piece and is supplied as is for assembly. In our tea set, components include the spoon, the ear, the cup, and the saucer. Individual components in the assembly diagram are evaluated by means of 3 elimination questions. The answers to these questions help determine whether the component can be eliminated without the loss of functionality through integration with other components. Components that could lose their right to exist in their current form are referred to as suspect components. A process is an action done on a combination of components during assembly. The application of glue to attach the ear to the cup is a process. If the component requires a protective layer like a coating, then the application of the coating is also a process. If the coating is on a component you buy, like a galvanized bolt, it's not seen as being separate, and the 2 are considered to be one component. Processes are also evaluated using the elimination questions, and those that could be eliminated are marked as suspect processes. A combined component consists of several components, but is delivered as a combination and cannot be easily dismantled. A ball bearing or photocell is a combined component. A main assembly is the product for which the assembly diagram is made. It consists of components, combined components, and sub-assemblies. In our case, this would include the saucer, the cup with its ear, and the spoon. A sub-assembly is a combination of 2 or more components, treatments, or processes which must first be assembled before they can be incorporated into the main assembly or another sub-assembly. In our example, the cup and its ear together form a sub-assembly. Let's now look at the 3 elimination questions to find suspect components and suspect processes. The first question is, should the component move or be able to move in relation to the preceding component in the assembly diagram? Look at the cup's ear. Does the ear need to move in order for it to function? The answer is no, and in fact, it doesn't move because it is glued to the cup. Then we ask, are there fundamental reasons for the component being made of a different material which does not otherwise occur in the product? Once again, let's look at the ear. The ear does not need to be of a material different than the cup. It too is made of ceramic, so the answer is no. The final elimination question is this. Should the component be fitted or removed separately, because otherwise assembly or disassembly of other theoretically essential components would be impossible? So in our example, we ask, does the ear need to be detachable in order to execute any of the processes associated with the product, like drinking or cleaning? The answer is once again no. If the answer to each of the 3 elimination questions is no, then the component, in this case the ear, becomes a suspect component and a candidate for integration with another component. Consequently, the process of gluing the ear to the cup also becomes a suspect process. If during the analysis phase, components or processes are marked as suspect, then a redesign can be considered. In our example, we marked the ear as a suspect component and the gluing of the ear to the cup as a suspect process. So now we ask ourselves, is there any way we could eliminate these suspects while retaining the functionality of the product and perhaps even improving it? We can make the ear an integral part of the design and production of the cup so that the cup and ear are a single piece of ceramic. This will eliminate the ear as a separate component and eliminate the process of gluing of the ear to the cup. Once the redesign is done, the results are incorporated into a new target assembly diagram. This final step of the DFMA process primarily involves the creation of a report in which we capture key information like details of the participants in the DFMA process, date and location it was held, key user requirements, outcome of the analysis including assembly diagrams, description of alternative designs, and finally the evaluation of key issues and action points. It is at the conclusion of the DFMA process that real work begins, where ideas and actions make their way into the real product, and when the results of the effort start to become apparent.
Okay, then you could understand this DFMA process very well from this video clip. So next we will discuss the benefits, DFMA benefits, the tangible. Shorten development time, reduce the development cost, enhance a smooth transition to production, and reduce the parts count, and simplified assembly process, improved quality, opportunities for mistakes, and reduced manufacturing cost, thereby reducing the AUPC and life cycle. And the benefits, once again, intangible benefits. What are the intangible benefits? Improve the communication within entire design team and promote teamwork, increase organizational ownership. Those are the benefits of the DFMA, design and manufacturing of design for manufacturing and assembly. And
DFMA is a methodology for optimizing a new concept.
And also, when we consider these DFMA principles, minimize the number of parts, minimize the number of fasteners, and standardize, avoid difficult components, use modular assemblies, use multi-functional parts, minimize reorientations, use self-locating features, avoid special tools, test equipments, provide accessibility, and minimize operation and process. These are some principles of this DFMA technique. And reduce, eliminate, combine, minimize, standardize, and productionize. These are the keywords of this DFMA technique. Next one, the continuous improvements. What are these continuous improvements? The continuous improvement, also called the CI, is a philosophy that approach the production process as a work in progress situation. This means that even if things are going really good, there are still places can be improved. So that's why when the process is going on, and in the production line especially, we can find this one. Get some sample and test it. And also the company has to always strive to better their process, which in turn will help them to cut cost and improve the productivity. Sometimes they will introduce different easy ways to fulfill that a certain process, as well as the quality will be analyzed. And also, if this is actually almost all the production lines do this continuous improvement. Finally, we have to discuss the just-in-time method. Actually, this just-in-time first introduced by the Japan, the Toyota car manufacturing company, because they have some overheads. So when the car is manufactured, all the raw materials and the spare parts must be stored in the warehouse, and when the workers handle those spare parts, sometimes it will damage, and so that they have the Toyota company had the real burden of managing these raw materials or the spare parts. So they introduced a method called the just-in-time method. That just-in-time method, today just-in-time is a process for achieving excellence in the manufacturing company based on continuing the elimination of waste. So the Toyota company will tell for the spare parts manufacturing companies that they have to bring their spare part in a certain day, because they are manufacturing a certain type of vehicle. For an example, Toyota Corolla, the production line throughout this week, they are going to produce the Toyota Corolla or else Axio. So the spare parts related to that car must be bring, and they can input that raw materials directly to the production line. Not they want to have the stocks before so that the fleet of lorries can be seen near in the production, near in the car manufacturing company, having these spare parts, and they are going to input the spare parts directly to the production line, so that the Toyota company need not to have the warehouse to store, and they need not to pay for the spare parts before manufacturing the cars, and they can save the money from and minimize the defects, as also minimize the damage of handling of those spare parts, so that they could get the advantages of introducing this just-in-time method. So that's why they could reduce the waste. Waste is considered as those things which do not add value for the product. Waste actually which do not add the value to the product, so that they could minimize the waste by introducing this just-in-time method. It accomplished this by moving materials to the necessary place at the necessary time. So so in the production line, the spare manufacturers must input to the necessary place of that spare part. So each operation is closely synchronized with the subsequent ones and make the possible, so that they will advise to input in the right time to the right vehicle, and the production will going on without any failure. So they could reduce the cost, as well as need not to have the warehouses, and damages are less, and they don't have the special staff to handle those spare parts, and the spare parts manufacturers must bring the spare parts and inject to the production flow. So then, new product development process. This is also very, very important. The normally called the stage gate product development process. Actually, the similar model could be found in for the modern innovation process also. The Cooper 1996 first introduced this concept, and there are several phases which with inputs and output specified beforehand, and gates in which the gatekeeper decide about the continuation of the process, and gate has a several constraints to see if that product satisfies that those constraints and can go through this gate. Activities were standardized, and then indicators of the process performance significantly improved. This is called the stage gate product innovation process. This is the idea. There may have the several ideas. So the idea will screen using this gate. Gate has a certain set of ideas: the commercial viability, then thereafter market segment size, and legal barriers, financial awareness, technology, and the financial matters. Everything consider each and every idea, and the satisfied ideas can go through this gate. And second also, then when the manufacturing process, that also must have a certain things to see, the scoping and build and business case, and see whether there may have a sound business case for that one, and analyzing those parameters, and go through that idea and development stage. In the development stage also analyze the technology and the material and other things, whether they are available, and if it goes through, then develop and testing and validation. Even in the testing and validation, sometimes it fails, and after getting through this testing and validation, can be launch the product. And when from the idea to the product, there may have several places to screen the idea, then idea, and finally develop the good product or service. These are the second generation one. Then gate ideas. Initial state actually must meet these one. Primarily assessment, market, technical and soft and financial financially analyze whether this idea has the considerable market share. Likewise, then it pass through this gate and must meet the and should meet the criteria gate 1 and market.
Recording stopped.
And technical reactions. Then second gate see some definitions, detailed market study, open operation, legal reviews, detailed technical appraisal, build the business case, product definition and product justification, and project plan also must be given. And if this passed through this gate also, this gate 2, once again analyze the product development and testing.
Recording in progress.
Product development and testing and marketing operations plan, cost analysis, monitor the market and consumer feedbacks. Then in the validation gate, in-house test, customer test, and normally if it is a software, user accessibility test, UAT. Likewise, do some testing method, trial production test, marketing, total business financial reviews also will be done. And if that product pass through the gate 5, the consumerization, that is implement operation plan and implement the market plan, and have the market plan, and this implement and launch. After launching, review the idea. That is called the stage gate product development process. Actually, this is one of the most important stage gate process from the idea to the final product development. So interdisciplinary view also we can find for this one, and concept development phase. First one, phase 2 system level design, phase 3 detailed design, phase 4 testing and refinement, phase 5 product ramp up, finally launch. Each and every gate must analyze the marketing, design, manufacturing and other functions. So then that's